Okay, in lieu of time, and we have four great presenters, I'm going to go ahead and get started. To the business partners of Ingram Micro, we want to thank you for joining the Ingram Micro IBM second half 2021 sessions. Today, we're going to be talking about containerization. My name is Cheryl Thompson. I'm your technology consultant representing the West Coast, and my counterpart, Mark Miller, is also on the line representing the East Coast. And today, with containerization, the topics we'll be discussing, Jim Smith is going to bring us a presentation on OpenShift, Red Hat on IBM Power Systems, and then tag teaming will be Jose Rodriguez and also Noah Gamak with IBM on persistent storage. And then bringing up the rear, Stacy is going to give us details with IBM Global Financing and how you can utilize IGF to finance these solutions. With that, I'm going to turn it over to Jim.
Hey, good afternoon, everyone. I have brought a gun to a knife fight. This is 15 minutes of talk time, and I've got, I don't know, 43 charts. Why in the world would I do that? I wouldn't bring any charts for 15 minutes. I'd probably bring about 5 charts to a 30-minute conversation. The reason I've done it is this is our client deck from Seismic that you folks would pull and customize as I would as well for what we're going to discuss with the opportunity at hand. So in kind of a vein of speed reading, we're going to do some speed charting, and I'm going to go through charts pretty fast and stop on the 4 or 5 charts where I think there's significant value and conversation to be had. Oops. So there's an agenda where we'll talk about things, but setting the table, right? Which of these personas are looking at cloud computing and why? We come at it from a infrastructure perspective, but really, we always work best when we bring value to our customers. So, these are what these folks in our customers are looking for. So the agility, security, trying to develop faster, using pattern-based approaches to have consistency, security, automation. So being aware of that, there's also other things at foot, right? Multiple clouds. Do I need a hybrid cloud? There's no question about it. You have one. You're not going to have a single cloud. You have dozens or hundreds of clouds. This is one of those charts that I very much like. Our good friends at IDC think that there's a couple of important trends happening, and this is consistent with my experience. 85% are migrating workloads from public clouds back to data centers. Why? Why would we do that? We'll talk a little bit about that as we go through the deck. And then 49% of public cloud apps installed today are going to come to private clouds. Why? Well, kind of a Pareto analysis on the right. Security, first and foremost. Next, followed by cost and a couple of other factors. Cloud is very much the tankless hot water heater of home renovation, right? You expect the myth of tankless hot water heaters is that you'll save a bunch of money and have infinite hot water because you won't be heating it when you're not using it, when you're on vacation. But the truth is that since it's infinitely available, you can't get the kids out of the shower and they just consume much more of it. Same with cloud, right? Cloud is not, as we know, less expensive. So some of the business factors, and we're going to hit these throughout the presentation, so I won't dwell, but we're looking to innovate in the business. We need to continue to have the same level of resilience and operations capability that we've always had, and especially on power systems, right? We run the business. IBM technologies in particular, whether it's mainframe or power with both AIXI and Linux, we need to interoperate in a hybrid cloud environment. So I like this chart as well. Why are we in a cloud? For great scalability, right? We can burst up. I don't have to invest in CapEx expenditures to have unused capacity on the floor for cyclical workload, for Black Friday, for those peaks workloads that otherwise the resource sits idle for. I can scale at will. However, the trade-off is less, control. I have to follow what my cloud vendor provides to me. Over on the right-hand side in our private clouds, we have infinite system control, greater security. These are all components that we are measured on and keep us in business. So the open hybrid cloud allows that to happen. If I am looking for a way to seamlessly transfer workload between both of these good constructs, I need a lingua franca to be able to translate between. And Red Hat and IBM think that that is OpenShift containerization. It runs everywhere and therefore allows us to move our workload where it's needed. So do what deploy what you have, what you build anywhere. That's the promise of OpenShift. And we're seeing that is mostly true. OpenShift is to Kubernetes what Red Hat Enterprise Linux is to Linux, right? Linux kernels run everywhere in our home automation systems, our cars, our watches. But the reason our customers run well is the packaging support, care and feeding for. Same with Kubernetes. Kubernetes has many services in different clouds. AWS, Google Cloud Services, Azure, all have their own Kubernetes-based services. What OpenShift gives us is the way to standardize and know that we have hardening, we have defined secure patterns implemented for operational excellence. In addition, from a power perspective, we're the systems of record, right? We run the business, and by providing capability of OpenShift in Power and co-locating Power OpenShift with other platforms on OpenShift, that gives us the best of all computing worlds to interoperate. So, existing monolithic applications. We are very much in the world of, relational databases, custom apps, machine learning. We have our big systems, and to that we connect down below machine learning, right? We have data warehouses, data marts, data lakes. We do inferencing against that data. We push data back and forth. The databases themselves tend to be off in an island of themselves, and then our own applications sit elsewhere. We co-locate these things in our data centers and run them, and have for decades. We understand and do well with running these operations. The downside is flexibility, cost, maintenance. We need to do more with less. So as we move towards, the middle, we can have existing monolithic applications interoperate with cloud services. So what this use case provides is the ability to have our big AIX Oracle, our big DB2 on I, our RPG scheduling and CRM, ERP capabilities running where they have and where we know how to. We have infinite customization that we have had add up over the years. All of that stays in place, and then we push out new front ends to do API calls back into that enterprise. Very quick return on investment, and allows us to modernize and leverage the capabilities. Then on the right, as applications do evolve, they are moving into a container-only implementation, which is interesting. And we are seeing this for Power as well. We'll talk about a couple of customer use cases in a chart or two ahead. We won't dwell on what OpenShift is. I think we would have that conversation with our customers. And in addition to OpenShift as the platform, what we derive from that is, patterns. We have templated capabilities, Red Hat runtimes, code-ready workspaces, IBM Cloud Paks. Various vendors have constructs that sit atop OpenShift and run efficiently and effectively. And what we have for Power is impressive, right? As we, as we put Linux on Power 2 decades ago, it was, what runs on it? Well, now everything runs on it. So across, the Linux ecosystem, the middleware, the dev ops languages and development platforms, analytics, databases, storage, it's all there. So Red Hat says that OpenShift provides significant business value. Well, what are the metrics? Again, I like this chart. It's simple, straightforward, and we can have a lot of conversation about it with our customers about the specific project we're doing. It's a faster development lifecycle. Awesome. And we do not only faster, we do more per year. Look at the payback in under a year, and then the return on investment for every 100 developers. IDC, thinks we're getting a $1.2 million benefit from basing our development on OpenShift. IBM, for our part of the equation, has been and continues to refactor our software delivery into Cloud Paks. And Cloud Paks are a packaging construct that leverages the capability of the middleware platform. So logging its consistent security access, where we do name resolutions, load balancing, all of those capabilities that we need for all of our applications sits in the OpenStack platform layer, and then the software sits atop and leverages those skills. So I'm not going to talk a lot about Cloud Paks, but we, like other vendors, have committed to delivering solutions on top of OpenShift. So here's what a Power perspective, a reference architecture for how Power addresses the new cloud architecture platform is: private cloud, public cloud, running on Power. We have our capabilities for Power systems, and they exist in the cloud as well. So when we're in Power VS in the IBM cloud, we're still running Power VM, Power VC, all those underlying technologies, and also running those same technologies when we're on Power in Google Cloud Services, Azure, and Amazon. So atop that, the OpenShift platform, and our software, Red Hat software, other ISVs sit atop. We're repeating some of the same things in different ways in a couple of these charts, but this is the last of the special charts in the deck. When you pull this down and customize it to discuss a particular implementation, what's unique here is that to the left we have classic LPARs sitting on Power systems. We all know and love and run these incredibly important applications. In the new paradigm, we are running the same workloads, and in addition adding OpenShift. So we have any number of VMs running on Big I, on Big AIX, on Big Linux if it's HANA, and we connect to that ancillary applications, front end, middle tier level apps that reach into those systems of record and provide the very modular, rapid CI/CD application constructs that allow us to leverage existing skills in application development and make our systems available through modern technology. So very powerful construct. We would care about this particularly for latent sensitive applications when we're trying to connect systems of record in a transaction-oriented manner. For example, charge card clearinghouses. If you make a charge card purchase, that will be resolved through a Power system. We can't have a Power system sitting locally and in the front ends in some number of clouds, many network connections away. We're going to want to co-locate those applications that have those kinds of characteristics. Other applications where latency isn't the issue, we'll certainly look for the geographic dispersity capabilities of having separate systems in different OpenShift clouds. So we have certainly, from a Power perspective, the opinion that our existing infrastructure is modern, capable, and provides private cloud capabilities. We augment that with the ability to run in Power VS on IBM cloud. You can run Power in other people's cloud. And then by using OpenShift, and we hope Cloud Paks, but other vendor solutions that sit atop OpenShift, you can combine those in whatever way makes sense. One quick talk, this is a separate discussion, but those on-prem resources are now usable by the minute through capacity on demand enterprise processor pools 2.0 dynamic capacity, where we'll charge for memory and cores by the minute. So we'll give cloud capability even when it's on site. And then by combining these, you can, how often do we go to start a new project and we don't have resources available? We procure some systems for some kind of new development or new release, and then, wait weeks or months to spin those up. We can now instantiate our LPARs and OpenShift in the cloud. We have a cloud Power Rack offering, which provides OpenShift in a appliance-like format. It's as simple as one node to 3 racks full of servers that are all doing OpenShift pre-configured, and some information about those, why we would consider it. Some discussions about Power Virtual Server in the cloud, which we talked about last time, where that exists. And again, we're speed charting. There is a learning path so that we can, do this on our own, build skills within our own, business partner organizations and with customers on how do I design and deploy. And then we have some reference architectures of whether it is, just stand it up and use it, whether it's, more high availability or clustering with additional architectures in other clouds. We have use cases that we'll talk about, and here they are for a summation of what our customers doing with OpenShift on Power. Is it real, Jim? This is a nice capability. It's absolutely real, and we're doing it in multiple industries or markets from an IBM point of view. I'm not going to read each of these, but here's where we have significant capabilities and wins. I'll talk a bit on the bottom. We have a couple of interesting wins that surprised me, right? It's intuitive that you would have our systems of record, big IBM I with DB2, RPG, big AIX with Oracle, and then you would have OpenShift next to it to reach in. Talked a little bit of latent reasons why you do that. This bottom, we have a large retail entity that is procuring, we just closed the deal, 6 1080s to run OpenShift, and HCL Commerce is we're not running big databases. Everything is fully containerized. So it's a full OpenShift deployment without the legacy pieces. So that's kind of interesting as us, long-term power guys might not be thinking that our platform is fully OpenShift exploitable. It certainly is. Some more of the personas and why they would care about it in words versus pictures. And then, figures lie and liars figure. We say it's faster, and here's how much faster. It gives you a lower TCO, and here's the math on why we're 68% cheaper to do it on Power versus alternate architectures. We can have those conversations. Security is a strength for us. And then here's the business drivers again and how we meet those. And then back to, we can try it free for customer opportunities in Power VS for a couple of different ways. Ingram can certainly help us with some IBM provided funding and a couple of different incentives. This isn't that call. We would talk, about lab services assisting. Red Hat also has services that assist. And that's it. So I have fully absorbed all of my time.
Thanks very much, Jim. While Jose is going to pull up his slides, if there's any questions, feel free to unmute yourself and ask away. Otherwise, you can utilize the chat to put questions in there. And I think Jim will be able to answer them via text as well.
Okay. Okay, can you guys hear me and can you see my screen?
Yeah, it looks great.
Okay, cool. Well, thanks, Jim. Thanks for setting this up. I'm Jose Rodriguez. I'm also a partner, technical partner architect, and my peer peer in crime is Noah Gambach, and we're going to go through a little bit of the storage in a containerized environment. So let's talk a little bit about why is it important. Okay, so containers by themselves, when they were originally created, were created so that they can start and shut down very quickly, right? Because of that, the architecture was decided that they would be stateless. What that means is that it will not remember, a container will not remember the state that it was in when it came down. It comes up at the same point all the time. So it means all the data, all the manipulation, any logic that was run is going to be lost. So in some instances, that's okay. If that's all you want that container to do is always come back at the same state and always do the same things over and over, that's fine. But as we discover that enterprises need to keep a history of what was being done, need to keep records of what the logic in those applications did, something came up. What do we do with it? How do we get to that data? And that term was called persistent storage. So we need some way of holding that data in some persistent storage that will be there every time a container is shut down and brought back up, or if it fails, if it has to come back up. So that's what is called persistent storage. And that's why it's important to understand how you use persistent storage with containers. The containers themselves make the application or the compute piece of it very flexible and mobile. Jim mentioned that you can run a container on-prem, you can run it in the cloud or in a private cloud or in hundreds of different clouds, right? And depending on where you need it and how quickly you need to start up, containers give you that capability. But the data is not there. So if you're using persistent storage, what are you going to do? There's two different ways that you can actually get to persistent storage. One is to have it in the central location, a global namespace, where no matter where that container comes from, you've got network connectivity to it. Issue with that, performance. It could be an issue. If you need things to be quick, you need millisecond response time. Depending on how far you are, if your container is running in New York and your data is in Los Angeles, that could be a bit of an issue, right? That and you also have a single point of failure because you only have one copy. Single point of failure can be taken care of by doing things like we're used to doing now, DR, making multiple copies, doing some kind of failover of that storage environment. So that could be taken care of, but we still have the main issue of performance. Now, the other way of being able to provide data to your container and take care of the performance issues is to have copies of the data closer to where those containers are going to be running. Okay, so it takes care of that. But so you've got an issue. Are you going to copy the data just before the containers are coming up, and do you know exactly where you're going to be copying that? And if you're going to do that, that's going to delay the starting of the containers. Right, so you've got to have some. If you're going to use this method, you've got to have a storage solution that can help you with the mobility of the data, to give it the same mobility that your containers have. Okay. I'm going to let Noah speak to you about container native and container ready storage.
Thanks a lot, Jose. So like Jose said, I'm a technology partner architect with IBM, and I wanted to talk a little bit about the two containerized storage classes that we have. So there's container native and container ready storage. And the way these are different is how they are interacting and working with the storage itself, right? So container native storage devices consume storage either as disk drives or external storage, and they create storage pools, right? So kind of the quick version is containers see that storage as a pool. Container-ready storage directly connects with the Kubernetes worker nodes via Fabric, right? So it's very quick. And it provisions volumes directly on the storage devices themselves. So there's really no change in how the storage is administered and managed, right? The other kind of neat thing is when we're talking container ready, this is how Spectrum Virtualize interacts with the storage. If we think about Spectrum Virtualize and external virtualization, we can virtualize over 500 different storage systems, right, on the back end of Spectrum Virtualize. So it's a really quick and efficient way to hook into the container storage environment. Back over to you, Jose, for the next slide.
Sure. So the other difference between container native and container ready is, think of as container ready, you can use the environment that's already out there. And basically what you need to do is just install a driver, we call it the CSI driver, which has the containers talking directly to the storage. In a container native environment, you could have software defined only and actually have containers inside your container environment. Let's put it that way, okay? So let's talk about IBM's storage solutions that work with in container environments. Really briefly here. Spectrum Scale, and this includes the ESS, the Elastic Storage Subsystems, because it runs the Scale software. It's we've seen a lot of how would I say interest in this, because when it comes to AI workloads, machine learning, deep learning workloads, business intuitive type of workloads, anything that has high performance type requirements, the Scale is a solution that many people think about. Okay, Cloud Object Storage. It's basically, think of it as you're building your own AWS S3 buckets, right? Where you've got more control of that, as Jim was talking about before, the difference between a private cloud and a public cloud or running an on-prem. You need more security, you need chain of custody, you need to prove that you've got it as opposed to some other vendor has got it, to whatever agency is requiring it. Cloud Object Storage is for that. Now, Spectrum Discover itself is not a storage repository, but it will help you manage what's out there in unstructured files. And we'll go a little more detail in each one of these. Spectrum Virtualize. Now, this is something that many people should be aware of already. It's what's running in the flash systems that you sell as storage subsystems. It's also in an SVC. But we also have a software version that will run in a public cloud. Okay, so it's got many benefits to this. And then, of course, Red Hat itself has Ceph storage and OpenShift container storage. You'll see a lot of things, OCS. They have now renamed it, rebranded to ODF. That's OpenShift Data Foundation, because there's a lot of other features and functions that was added to it. So let's go a little bit more detail on some of these solutions. Okay, as I mentioned before, Spectrum Scale, its old name was General Parallel File System. That should give you a little hint of what it is, the parallel piece of it. It's for high performance requirements, okay? Because it can run IOs in parallel. It can split your file and you actually can get pieces of it quickly because of its parallel processing, okay? But it's not only a performance environment. It provides you a way of being able to create a storage environment, a repository with ILM features in it, information lifecycle management features in it, where you can move data between different tiers of storage, putting it in the right place at the right time, right? So if you need something to be quick, you're doing some kind of a machine learning run at the moment, you probably want it in Flash. But if those files are not being used anymore, you can use them move them into disk, or maybe even into tape. And Scale does that for you with policies automatically. So it's easier to manage a big environment like that, okay? And with ILM, of course, you get cost and performance benefits, right? Scale itself, there are versions where you can use erasure coding. It's got replication. You can create snapshots of a file system. You can have encryption at rest and in flight. It's got a lot of other features that give you integrity to your data that's there. It also has a feature where it's called AFM, Active File Management, where you can actually have, let's call them smaller scale environments at closer to where the user might be. Think of the user being the container, where you can have caches of the data that those containers need. So hence the mobility factor that we were talking about before. You have to have scale making copies of this data into these local repositories, local caches, right? And you can set up rules on, hey, go out there and look to see if the file's been updated and go get a copy of it, or don't. Or you can set up policies where it makes a copy at the beginning of the day or at certain times of the day if you want. Or if you make changes to the local copy of the cache, should it be replicated to the other sites? Okay, so it gives you flexibility to do those things and the mobility of the data, right? So taking care of that issue that we had up front with persistent storage. I think Noah is our COS SME, so I'm going to let Noah talk about cloud object storage.
Yeah, so let's dig into IBM Cloud Object Storage a little bit more here. So it's very flexible. Sometimes we say IBM COS is like the Swiss Army knife of storage, but it can be very cost effective as well. And it's extremely scalable, right? So you can grow up at or above the exabyte kind of scale with COS, and it's used for unstructured data. So like Jose said, this is almost like a build your own Amazon S3 bucket within the customer's own data center, right? So I know it's called Cloud Object Storage, but you do have the option to use this as an appliance within the customer's data center or across multiple different geo-dispersed locations, right? And that's a really kind of big feature with COS, right? Is that you can spread it out, spread your data out across multiple different locations, maybe within different countries and things like that. All accessing it at different levels, and you get really high throughput with it as well, right? So you can have multiple read-write sources and continue to work with it. It's almost like a build your own Amazon S3 cloud, like Jose said. And COS has a really great integration with Spectrum Discover, and I'll actually talk about Spectrum Discover a little more on the next slide. But imagine that you're taking, back to the COS slide, Jose, I wasn't quite done. Imagine you are taking all this data that's geo-dispersed, so it's all over the world, and you're categorizing it and putting tags on it and running reports and able to search it and things like that, right? COS can be very cost effective. I've seen COS used as a substitute or instead of tape for backup environments. It has a really great story from a security perspective, right? Worm compliant, so write once, read many. And the secure slice encryption that we use really cuts this data down and divides it over time, right? Imagine your data is online and ready to go, right? So in today's 24/7 world, you're able to always access it with no downtime or data migration. Now the next slide, please, Lisa. So on the last slide, I mentioned Spectrum Discover. What Spectrum Discover is a software piece that allows for metadata tagging of your data. And you can use it for file, object, on-premise, and cloud data, right? So say you have data maybe spread across 5 different platforms. Spectrum Discover has a pretty great use case, right? Being able to locate and classify your data. So what lives where and where does it kind of fit in, right? As far as from a tagging perspective, right? What's relevant and what's not, that kind of thing. It's automated. So once you set up rules and policies within it, it will automatically catalog and index your data for you in real time. So no going back and tweaking things, that kind of thing. Excuse me. You can also do searches, right? Automated searches and things like that. So maybe you're looking for specific trends within your content, maybe specific patterns, things like that. There is custom reporting within Spectrum Discover as well. So if you want to run reports across billions of objects or files within your environment, you can absolutely do that as well. And it really just is giving you that insight into your data at the end of the day, with the custom tagging and content tags as well. So if you're looking for particular things within your environment, you're easily able to pull based on those tags. You can also automate data workflows with custom action agents as well. And kind of the last bullet just mentions that we can easily index video or images. We know those are usually the larger files within an organization. So imagine you're able to easily tag and pull exactly what you need because of Spectrum. Next slide, please.
So this Spectrum Virtualize. This is really something that most of all should know virtualize fairly well. It is what's running on our flash system storage subsystems. It's also the software that has been running on an SVC, the SAN volume controller, for almost 20 years now. I guess it's really 18 years or so that's been out. It gives you the capability to virtualize, use other people's storage, as Noah mentioned before. Give you that a whole entire pool of storage. Instead of having silos of storage, you've got one giant pool of storage. You have one method of doing snapshots, copies, remote replication. And we have now extended that capability out into the cloud so you can run Spectrum Virtualize in a public cloud. You can run it in AWS. You can run it in IBM's cloud. Soon it's going to be Microsoft Azure. And GCP, Google is on a roadmap, and so is Oracle. So think of what we can do with that. You can have on-prem running a flash system. You can have the data being copied into AWS, and then you can bring your containers running in AWS whenever you need it quickly because you've made copies over there. And now when you really have, as Jim mentioned before, that Black Friday incident or event where you need to bring things up really quick, you can bring up those containers up in AWS, and you've got copies of data over there, so they can be running almost instantaneously. Be able to handle that. And then, by the way, when Black Friday is over and that you don't need those resources anymore, you don't need to pay for them, shut them down. And you can then do the reverse copy and any changes that were made there, put it back to on-prem and let those applications run again in just on-prem. Okay, so there's a lot of benefits to Spectrum Virtualize, and we can spend a lot of time in here. What I'll offer to any of you, if you send me an email, I can do a whiteboard session for you, kind of showing you what a Spectrum Virtualize environment, how you might want to talk to your customers about that, and how you might start including public clouds. And for those customers that are not into containers yet, and you want to be a trusted advisor, you want to start talking about, the industry is moving that way. It is a paradigm that that people are moving towards. This is a way of getting yourself set up, your environment ready for that container environment for when you're ready, whether it's on-prem or on the public cloud. Okay. I think Noah, I'll let you do the Ceph storage.
Thanks a lot, Jose. So yeah, let's talk a little bit about Red Hat Ceph storage now. Red Hat is open and extremely scalable, and it can actually do block, object, and file all within their one platform. So pretty neat, right? That you can do kind of all three different protocols, right? And it can scale up within the petabyte range, right? So it can grow to be extremely large, and it can help you provision a lot of virtual machines or hundreds of virtual machines, right, with it. With Ceph, there is no single point of failure, so you can have maximum uptime when you're using Ceph storage, and it's extremely secure as well. So you can have your data distributed among different servers and disks dynamically. I was actually looking at, there are trials and things like that of Red Hat Ceph storage, so if you wanted to go download it and maybe try it out across different servers or disks within your environment, you can absolutely do that. It's really neat because it's really just spreading your storage out across different hardware, right, essentially. And it can do some really neat self-managing and healing and things like that. And it's easy to install and simple to manage. So yeah, I think it's back to you again, Jose.
Yeah, I get OpenShift Container Storage, or now actually OpenShift Data Foundation, and it's basically it's a consolidation of Ceph and some other features of OpenShift storage. By the way, most of customers that are starting to or just playing around or getting into a container environment usually go with the Red Hat OpenShift, either Ceph or the ODF storage. It's a little easier to install, easier to manage at that point. It does have its limitations. As you notice, Ceph was petabytes of storage. If you needed to go into exabytes, you're probably talking about Scale or COS, right? It is primarily written and used for storage-rich servers. So even in the cloud, you would have servers that have storage in it, as opposed to a storage environment. So it's got those kinds of limitations to it. But ODF also includes other things like being able to do snapshots of file systems and some other features in there. Just to give you a high level introduction to what Ceph and OCS or ODF is. Okay. Let's move forward because. All right. So. We do have I'm sure you've heard of Cloud Paks from IBM, which is basically packaged environments, a whole software stack for specific functions and features that you might need or applications, right? You've got things like Cloud Pak for data, which is basically a data fabric creating the environment for an AI or machine learning or a deep learning type workflow. You've got Cloud Pak for security, just as exactly as it sounds. You've got some multi-cloud integration. You've got now what's called Watson AI Ops. It's really just using Watson to look at your infrastructure, your whole environment, and maybe giving you warnings and alerts when certain issues surface. Okay, but if you're using Cloud Paks, a way of being able to get any of these products that we just talked to you about in a package with one single license, and you can use any one of those solutions in it. Storage Suite for Cloud Paks is the way to go. Okay, like I mentioned, it's got the licensing for Scale, Cloud Object Storage, Discover, virtualize in the public cloud, and for Ceph and ODF. Yeah. Noah, you're the Spectrum Protect Plus SME. I'll let you speak to this.
Thanks, Jose. So yeah, this is a architecture slide for Spectrum Protect Plus, backing up a Kubernetes or OpenShift cluster environment. And I actually want to really focus on the bottom kind of section of this slide, because at the end of the day, I think the question that we should answer is, what is Spectrum Protect Plus giving you in your container environment? And they really provide two things. It provides the capability to create snapshots of your container environment, of your persistent storage that lives in Kubernetes or OpenShift. So imagine you're just taking a snapshot, as you see at the kind of bottom left, the CSI snapshots mentioned there, and then you're able to recover from those snapshots back into your production cluster. It's kind of a simple use case, right? You're really just taking a snapshot of your volumes, and then you're able to recover from those different point in time snapshots. On the bottom right, you'll see vSnap servers mentioned. What that is that's your backup repository. So Spectrum Protect Plus is creating backups of your containers and then putting those backups on external storage, right? Physical storage hardware somewhere else. That's kind of the second use case, right? So we talk about just creating snapshots, and then we're talking about creating backup files that are going to live on other hardware. Then we can take those backup files and push those off to the cloud. If you look on the bottom left, we mentioned the IBM cloud, Tape, Amazon S3, Azure Blob, or maybe Red Hat's cloud as well, right? So really there are two use cases and two things that Spectrum Protect Plus does. It can create backups that are backup files and then offload those to some kind of secondary storage, be it Tape or the cloud or something else, or it can create snapshots of your data that lives on your containers. Back to you, Jose.
Thanks, Noah. Actually, that's very important, what you mentioned there, the two use cases there. A lot of people start creating container environments, and they've even gotten to the point where they're creating persistent storage, but they forget about the data resiliency, and that's where Spectrum Protect Plus really helps. And the two use cases that Noah mentioned are extremely important in an environment like that. So very quickly, I'll go into, Jim mentioned something about 85% of customers are returning back from the cloud, and some of those workloads may be container environments. And so, how can you help your customer bring those loads back on-prem? IBM recently announced and now GA'd a solutions called Spectrum Fusion, and basically what that is a software stack. It's in its first iteration, at the first release, it's actually an appliance. It's the Spectrum Fusion HCI, Hyperconverged Infrastructure. So it includes the storage, it includes the servers, it includes network, and all the software stack in it. In the second half of next year, well, actually near the end of first half, let's put it that way, we're going to have a software version of it, so you can actually run this environment out in public clouds. But what this does is gives your customers an environment to quickly create a container environment with persistent storage, with that mobility that we were talking about, with Spectrum Scale in it, so that they can bring in workloads quickly back home, let's put it that way, or on-prem. It also is for those accounts that are first getting into containers and they want to do it on-prem and they want to do it quickly. So you've got two entry ways to talk to your customers about this. Okay, very quickly here the components that are in the Spectrum Fusion environment. And really, when you talk to your customers, talk to them about the bottom half of this box. Really, what Spectrum Fusion is providing your customers is all that. It's a storage platform, and it gives them all of the services that you can see up above, and it's been integrated and certified to work in a Red Hat OpenShift environment. Okay. With that, that's all we have. I believe we now pass it over to, who is it that we pass it over to, Mark?
Stacy.
Stacy.
Hey. All right, let me set up here, Microsoft PowerPoint. Let's hope this works. Oh my gosh. It's asking me to, Zoom does not like. Hey, Cheryl. Do you have my slides?
Yes, Mark has them. Mark, can you go ahead and pop up Stacy's slides for her?
Yeah.
Sorry, it's asking, it says it's allowed, but I don't use Zoom
we
very.
have the backup. We're ready.
Yeah, I don't use Zoom very often, so I guess I have to figure that one out now. But all right, you have figured out the solution that your client is looking for. It may include some software, some services. It has some of the container stuff. It may have some of the system hardware on site, and you got a quote ready to go. And maybe there's some 3-year software in there that you want to sell them, take advantage of potentially some of the back end, locking in this customer for 3 years on the software piece. But you got one quote. The problem is either one, your customer doesn't have the budget. 2, your customer wants to spread out that cost to match up with the revenues. Potentially there's a ramp up or deployment period that's going to take before they get the benefits of the solution. So they need to figure out how to match those costs with the timing of when it'll be available. That's what we're here for. We are here to help take these solutions, whether it consists of, IBM, maybe it has to be a little bit of OEM in there, maybe there's some partner services, and figure out what's going to work best for your client's budgetary or financial needs. And so if we can move to the next slide, Mark. So I just noticed when I was pulling up these slides, we recently changed our name. We are now IBM Financing, which makes it very interesting because the nomenclature or the acronym is if. So in my head, I'm already starting to try to figure out how we position this. So if you include if, and we are working with you side by side proactively at the beginning as you're working through these solutions with your client, we can help you increase margin, deliver value, and improve your DSO. And how do we do that? Well, number one, by presenting just payments, up front and just showing like maybe a monthly cost or a quarterly cost, it starts planting those seeds into the client's head as to, wow, we can afford that. That's something that's in our budget, which helps expand potentially what they can all acquire. So if we give them nuggets, it helps them think bigger. Also, it shows affordability, so hopefully they don't haggle as much on price with you, thinking they have to cover the total cost of the solution in this year's budget. We deliver value to your client. Usually we get brought in on the tail end because after you've figured out the solution, what it's comprised of, you take it to the individual you're working with at the client location, and they have to go take it to their finance office. And for whatever reason, they all of a sudden saying, well, we need to do this, or we need this payment structure. And so then it becomes a whole nother round of negotiations. We can meet those payment terms without having to bring down and impact the total cost of the solution by delivering, whether it's a ramp up payment structure, whether it's quarterly payments, whether it's deferrals. As long as the client qualifies, we're here to help figure out how to meet their needs without it impacting the total cost of the solution. And best of all, we pay you guys, the partners, in 7 days from the day we receive the last document, which is typically the invoice from you. So within 7 days, the money is in your bank account if you're on electronic funds with us, which most everyone is. So that's the value to your clients, to you, on bringing us in and proactively working with us, how we can help you maintain your margins and potentially grow the solution. Next slide, Mark. So why is this important? So I like the blue box in the middle. 68% of customers surveyed said availability of leasing and financing was important in their partner selection process. A lot of times you're competing and they're looking at 2-3 bids among different partners and what you're bringing to the table. And as a trusted advisor, I will tell you the biggest partners usually are delivering some kind of payment, whether it's in the bottom of their statement or in the print saying, hey, we have this available to help make this affordable. So just by planting that seed and saying, yes, we have the capability. And on top of that, IBM subvenes down or works with us to give a very attractive buy down on the rate that for the most part, it beats most customers' cost of capital. So when they look at it, whether it's internal money they're looking at using, or we're competing against another financing institution, we have the best rates. And also by doing that, we've shown in IDC surveys that the probability to win goes up when you propose a financing solution with it. Not that they always take the financing solution, but just showing that you're trying to meet all the requirements. So next slide. So what's in it for you? We understand financing sometimes we have a few documents that they may have to sign. It may take some time. So we pay our partners, and there's 4 areas of our incentive plan that any IBM partner with our attachment qualifies for. You can earn a transactional fee. That's in the first area. Depending on the amount of volumes you do with us, it's either 0.5 point or 1%. If it's a new client that hasn't had any financing with us in the last 24 months, you earn just a set amount for that deal if it's registered. So by engaging us early before anything's set, we can qualify that deal for the new account bonus and potentially earn some incremental flat money for you. Also, through the distributors, we have what's called Fast Start. And this is money that's can be utilized. The distributors approve it. David Bishop at Ingram is the representative, and we nominate up these deals for flat sum money to the partners. And then finally, incentive for growth. The more you do, the more money will pay out, and that gets reviewed quarterly. And we send a check after you hit the thresholds shown on the slide. So we're here to help bring your deals to fruition and help you close the deals sooner and at the highest possible margin, leveraging a payment schedule. So how do you engage? The last slide, Mark. So reach out to me. As I mentioned, David Bishop at Ingram is also available. But basically, we take your quote and then you provide us what's the term and the schedule they're looking for, what type of financing we're looking at, and is there any sales taxes that we need to take into consideration and finance. So reach out. We look forward to working with you. We have a team for each of the partners that has an assigned individual that can come in and work with you so that we can help and be proactive on these transactions. And with that, I'll send it back to Mark and Cheryl, and thank you for including IBM financing.
Thanks, Stacy.
Thanks, Stacy. Thank you, Jim, and thank you, Noah and Jose. Are there any questions from the partners or the people who are attending the session? Any questions for our speakers? Also, I would like to bring to your attention in the chat box, we have our last and final session on December the 2nd at 1 p.m. Eastern. It's going to be on IBM data analytics and AI solutions. And you can click that link and go ahead and register and don't have to worry about it. It's already on your calendar. So I want to thank you again for attending the Ingram Micro IBM Technology Consultant sessions. And this information will be posted. We have a YouTube link and we will have a link to the presentations. Thank you so much for attending, and thank you to all our speakers.